Hello again, this is Coach Dorf. We're now in section 4.4, and we're going to look at problem number 51, which is a problem like homework problems, but not a homework problem. So this problem says to find this limit. So to do that, let's do, the first step I would do is do a direct substitution. So I would find the limit as x goes to 1 from the right of the first term, x over x minus 1. If I do a direct substitution, then I'm going to get a 1 in the top, and I'm going to get something that gets close to 0 in the denominator. So a non-zero number over 0 means that that's going to go toward infinity. So the limit there is infinity. Likewise, if I do the second term, the limit as x goes to 1 from the right of 1 over natural log of x, the natural log of 1 is 0. And so I get 1 over something close to 0, which is infinity. And so I get, we have the indeterminate form of infinity minus infinity. Now, this makes sense because when we look at the original problem, inside the parentheses, we have something minus something. So if you're going to be using, if you're in a problem that needs L'Hopital's rule and you have something minus something, you're going to always use this technique. And the technique is to combine the two terms so that you get one term with a rational expression. So something that looks like a fraction. So what we need to do is combine the two terms. So that means we're doing x over x minus 1 minus 1 over natural log of x. I'm going to combine these together. To do that, I'm going to get a common denominator. In this case, the first term I'm going to multiply by natural log of x over natural log of x. And for the second term, I'm going to multiply top and bottom by x minus 1. Then when I do that, I'm going to get x natural log of x over the denominator minus x minus 1 over the denominator. And now when I combine those together, I get x natural log of x minus, now be careful here, you have a minus in front of that next expression. So I'm going to put it in parentheses because it's subtracting the whole thing on the top. And my common denominator, I will put there in the bottom. And so when I distribute this negative here, it goes to both of these terms here. It's now going to give me x natural log of x minus x plus 1 over the denominator. All right, so now we have the original problem was the limit as x goes to 1 of the quantity x over x minus 1 minus 1 over natural log of x. We've now rewritten that like this. All right, so that's our new problem. And now if we do direct substitution, so note, if I do the limit of the numerator, so I have x natural log of x minus x plus 1. So I put in 1 in there, going from the right. I'm going to get 1 times 0 minus 1 plus 1, which is 0. And for the denominator, as x goes to 1 from the right, I get 1 minus 1, which is 0, times the natural log of 1, which is 0. So I get 0. So now we have, indeterminate form of 0 over 0. And you might think at this stage, well, why did I do all that first stuff? Because it didn't really help. Well, it did help. when we have infinity minus infinity, we have to rewrite that in a form like 0 over 0 or infinity over infinity, so we can use L'Hopital's rule. Now that we have it rewritten as 0 over 0 in the limit, and we have this indeterminate form of like that, we can now use L'Hopital's rule. So we use L'Hopital's rule because we have that the limit has the indeterminate form of 0 over 0. So we've got the limit as x goes to 1 of x natural log of x minus x plus 1 in the numerator. And in the denominator, we have x minus 1 in parentheses times natural log of x. So L'Hopital's rule, we're applying it right here, means that we now take the, when we do the limit, we take the derivative of the top. We have this over the derivative of the denominator, which is this. Okay, so now when we take those derivatives, what do we have? In the top, we're going to have to use, this is going to have to be a product rule, because we have x times natural log of x. So we're going to have the first times the derivative of the second plus the second times the derivative of the first. All right, minus now we do the rest of it. So we have the derivative of negative x, which is minus 1, and plus the derivative of 1, which is 0. In the denominator, we also have to use the product rule. So this also has the product rule because we have this. So I'm going to get the first, x minus 1, times the derivative of the second, plus the second times the derivative of the first. All right, so now we go ahead and we carry out the rest of our differentiation. On the top, we have x. Okay, the derivative of log x is 1 over x plus log x. Derivative of x is 1. And then we have minus 1. Okay. And then the denominator, we have x minus 1 times the derivative of log x, which is 1 over x, plus log x times the derivative of x minus 1, which is just 1. And so if I rewrite that, I get the limit as x goes to 1 from the right of 1 plus natural log of x minus 1 over, and then I'm going to distribute, I'm going to put some reds in here. I'm going to distribute this 1 over x to both terms here. All right, and so that gives me x times 1 over x is 1. 1 over x times negative 1 is negative 1 over x plus natural log of x. And I can notice also that this 1 and negative 1 in the numerator cancel out. And so if I wanted to, I could rewrite this, look a little bit cleaner as the natural log on the top over 1 minus 1 over x plus natural log of x. All right, so now we do again the direct substitution. So what's the limit as x goes, I'll put a little note here, as x goes to 1 from the right of the numerator, natural log of x. Well, the natural log of 1 is 0. And in the denominator, we have x going to 1 from the right of 1 minus 1 over x plus natural log of x. So when I substitute 1 in there, I get 1 minus 1 plus natural log of 1, which is 0, so I get 0. So again, we have, this is indeterminate form of 0 over 0. And you might think, well, maybe I did something wrong. No, not necessarily. You can get, once you do L'Hopital's rule one time, you can still get it into an indeterminate form, and you have to do L'Hopital's rule again. Not necessarily wrong, okay? So we're going to use L'Hopital's rule again. Oops, okay, let me rewrite that. Use L'Hopital's rule again. All right, so now I've got the limit as x goes to 1 from the right of natural log of x over 1 minus 1 over x plus natural log of x. And so using L'Hopital's rule right here, that means I take the derivative of the top. So I have d dx of natural log of x over the derivative of the denominator, 1 minus 1 over x plus natural log of x. So when I do those derivatives, on the top, the derivative of natural log of x is 1 over x. And the derivative on the bottom, derivative of 1 is 0. Derivative of 1 over x. So let's just do that off to the side here. So we have d dx of, I'll just put the negative sign there, negative 1 over x. So I'm going to write that as d dx of negative x to the negative 1 power. All right, and when I take the derivative by the power rule, I bring the exponent out front. So I have a negative times a negative 1. It's going to give me a positive x. And I reduce the power by 1, so I get minus 2. So that's going to be 1 over x squared. All right, so I included the negative there. So now I'm going to have 0 plus 1 over x squared. And then the last part is the derivative of natural log of x, which is 1 over x. All right. So now when I substitute in my value x equals 1 here, I get 1 on the top, then I get 0 plus 1 plus 1, which is 1/2, and that's the correct final answer. Hopefully that makes sense.